Good evening, students. Today we are going to discuss about the coordination compounds. So, in your syllabus, the next chapter is coordination compounds. It is very important for your mains and NEET exam. So, it is the scoring chapter. So, we have studied in D block elements that transition elements can form number of complex compounds. So we have seen the special properties of transition elements. In that we have seen that transition elements can form the complex compounds. So what I mean by complex compounds? So these complex compounds are nothing but coordination compounds. So for example, so there are different for example, K4 FeCN6. So this is the complex compound. So many examples are there, and these complex compounds they exhibit different colors. So transition elements compounds which are complex in nature can show the different colors in the complex formation. So they will have different colors and different properties, special properties and special characteristics are there for these complex compounds. So these are different from salts of S and P block elements. So S block element and P block element form salts which are mostly are in white color. So but transition elements can form the colored complex compounds. Their compounds are so contain different colors, purple, yellow, pink, so many different attractive color complexes are formed by the transition elements. So let us see types of compounds. Generally the compounds are classified into two types: simple salts and addition compounds. Let us see simple salt. Simple salt means, so for example, sodium chloride is the simple salt. So it is formed by reaction of acid with base. So when we take HCl and NaOH, we can prepare NaCl salt, and water is the byproduct. So this NaCl, when dissolved in water, so it can dissociate into Na plus and Cl minus aqueous ions. So this is called simple salt. So simple salt forms individual ions when it dissolved in the water. So some compounds are called addition compounds. So addition compounds are nothing but they are prepared by mixing of two or more stable compounds. So for example, if you mix KCl, MgCl2 and water by taking a stoichiometric proportion, means we should maintain correct ratio of these compounds. So when we maintain that stoichiometric ratio, they can form the addition compounds. For example, this is the carnallite, KCl, MgCl2, 6H2O. So this is the addition compound. By adding two stable compounds, we are preparing the addition compounds. For example, carnallite. Carnallite formula is KCl, MgCl2, 6H2O. And other example is potash alum. So potassium alum is prepared by adding K2SO4, potassium sulfate, aluminium sulfate, and 24H2O. So by maintaining this ratio, we can prepare this K2SO4, Al2SO4 taken twice 24H2O. So this is the formula of potash alum. So it is a addition compound. So when these addition compounds are two types. One is double salts and one is complex compounds. So complex compounds are nothing but addition compounds. So but what is the difference between these double salts and complex compounds? Double salts means, so when they dissolved in water they lose their identity. In for example, this carnallite is a addition compound. So when we dissolve in water, this will form different individual ions. For example, if we observe this compound, so it can form K plus aqueous K plus, aqueous Cl minus, and aqueous Mg plus 2 ions. So this all individual constituent ions are formed by dissolving in water. So this is completely ionized into its individual ions. So they loosed their identity on dissolving in water. So means we, by seeing these ions, we cannot say from which compound these ions are formed. So means their identity will be loosed. And complex compounds, what is the difference between double salt and complex compounds? So complex compounds are also addition compounds. So by adding different stable compounds we can prepare, but they retain their identity in solution. So they retain their identity in solution. So means what? So for example, K4FeCN6, it is a complex compound. When it dissolved in water, it will form K plus and FeCN6 4 minus. So it doesn't forms the Fe plus to Cn minus individual ions. So it forms some complex ion. This is called complex ion. So that type of compounds are called complex compounds. So means they doesn't lose their identity when they dissolved in water. This is also have same similar properties with this compound. So by seeing these ions, so we can say, so by seeing this K plus and FeCN6, we can guess that the compound is this one. So for example, unknown salt is given to you. This is the unknown salt. So when you dissolve in water, they will form K plus and FeCN6 4 minus. By seeing this ions formation, we can expect the compound is this one. But by seeing these ions, we cannot expect. So the addition compound is this one. So means they lose their identity, but here they will retain their identity. This is the difference between double salts and complex compounds. Next, characteristics of coordination compounds. It is a compound formed by metal. So generally complex compounds or coordination compounds are formed by the metal when metal associates with some species. That species are called ligands. So for example, in FeCN6 4 minus, this is the complex compound. In this iron is the metal, and this Cn minus is called cyanide ion is called ligand. So ligands are species which donate electrons to the metal. So this is the electron donor here, and this is the electron acceptor. So this Fe plus 2 is the acceptor and Cn minus is the donor. So this is nothing but coordinate covalent bond. And next, coordination number. So the total number of monodentate ligands attached to the central metal in a complex is called coordination number. So coordination number is the number of sites occupied by the ligands. For example, NH3. NH3 is the monodentate ligand. So it occupies only one position, one coordination site in the metal. In this around this metal, only it can occupy only one site, one position. So coordination number of copper is here in this compound. How many monodentate ligands are there? 4. Means coordination number is 4. So that is the number of monodentate ligands attached to the central metal is called coordination number. And let us see types of ligands. So in that, first type is monodentate ligands. Monodentate ligands means they uses only one atom as the donor atom. For example, Cl minus, Cn minus, SCN minus, thiocyanate, cyanate, chloride, amine. These ligands are monodentate ligands. So let us see some examples for monodentate ligands. So they may be neutral. For example, this ammonia is the neutral. It doesn't have any charge, and it may be negative. So let us see neutral monodentate ligands. So here H2O, it is the name of this ligand is aqua. NH3, the name of this is amine. CO, carbonyl. NO, nitrosyl. CH3NH2, methyl amine. And pyridine and diethyl ether. So this is also monodentate neutral ligands. These are some examples. And negative ligands. Negative ligands means they are negatively charged species and uses only one donor atom to form the complex compound. For example, F minus, Cl minus, Br minus, I minus. So the names of these ligands fluoro, chloro, bromo and iodo. So these are negative monodentate ligands. And let us see some more examples. This is hydroxo, this is cyano, this is oxo, sulfato, nitro, nitrito, thiocyanato, isothiocyanato, nitroso, and azido, and acetato, and hydrido. So these are some negative monodentate ligands. So this sulfate ion both acts as monodentate and acts as bidentate also. So we can take examples to both monodentate and bidentate. Polydentate ligands, so which uses more than one atoms as the donor atoms. So they uses more than one atoms to donate to the metal cation. And here oxalate is the structure of oxalate is C double bond O minus and C double bond O minus. So C2O4 2 minus. So this is the structure of oxalate, CO minus CO minus. So it is a bidentate ligand. So this comes under polydentate ligand. So polydentate means it may be bi, di, tridentate, tetradentate, like that. So one more example is this is the tridentate ligand. So it is called diethylene triamine. The name of this ligand is diethylene triamine, and it uses this nitrogen, and this three nitrogens, three donor atoms are there, and it acts as tridentate ligand. And next EDTA, ethylene diamine tetraacetic acid, is called EDTA. So the structure of this EDTA is like this: NCH2 CH2N. This is ethylene diamine. So in that hydrogens are replaced by acetates, tetraacetate. So ethylene diamine tetraacetate is called EDTA. So EDTA is a polydentate ligand. So it has poly donor atoms. Nitrogen is the donor atom. Here nitrogen, here oxygen, here oxygen, here oxygen, and here oxygen. So it is polydentate ligand. So it maximum it can donate hexadentate. So means it can occupy 6 positions coordination sites around the metal. Next, bridging ligand. The ligand which simultaneously binds two metals. So it acts as a bridge between these two metals. So that type of ligands are called bridging ligands. So here the chlorine acts as bridge between two palladium metals. The next type is ambidentate ligands. So ambidentate ligands, it is capable of bonding through one type of donor atom in one complex and with another donor atom in another complex. Means, for example, NO2 minus. So this have two donor atoms, one nitrogen and one oxygen. So it can use either nitrogen or oxygen to bind with metal. That type of ligands are called ambidentate ligands. So for example, so in this compound it uses nitrogen as the donor atom, and in this compound it uses oxygen as the donor atom. When it uses nitrogen as a donor atom, it is called nitro. And when it uses oxygen, this is called nitrito. So this is nitrito and this is nitro. And one more example is Cn minus. So Cn minus can use either carbon or nitrogen as the donor atoms. For example, here this in this compound, here it uses carbon. It is called cyano, and it uses nitrogen as the donor, and it is called isocyano. So the names of ligands are also changes as changing the donor atoms. Nitro, nitrito, cyano, isocyano. And this thiosulfate ion, thiosulfato. So here it may be uses sulfur or it may uses oxygen to donate to the metal. So when it uses, this is called thiosulfato S. This is called thiosulfato O. So this is the ambidentate ligands. Next, fourth type of ligands are flexidentate ligands. So it is a polydentate ligand which can bind to a metal through different number of its ligand sites. So for example, EDTA is it has 6 6 donor atoms. So maybe it can occupy 6 positions of metal, or it may occupy 5 positions, or it may occupy 4 positions. Means it acts either may be hexadentate, or it may be pentadentate, or it may be tetradentate. So this is called flexidentate ligands. So they either use 4 sites or 5 sites or 6 sites to bind with the metal. And sulfate, this is also a flexidentate. It is bidentate ligand and it is a flexidentate ligand, and it is also a monodentate ligand. So for example, in this complex, sulfate uses only one donor atom. It occupies only one coordination position. But here it occupies 2 coordinate positions. So here it is acts as monodentate and here it acts as bidentate. So that type of ligands are called flexidentate ligands.